lesson 13, we learned about the discriminant, which is equal to b squared minus 4ac, and we learned about how the discriminant tells us what types of solutions a quadratic equation can have. If the discriminant is equal to 0, we learned that this quadratic equation had one real repeated solution. So the graph for that, if it only has one solution, it only has one x-intercept, because the solutions are where the graph is equal to 0, which is the same thing as their x-intercepts. So that graph could look like this, where there's the only one x-intercept. And that would happen if a was negative and the graph opened down. But if a was positive and the graph opened up, the graph may look like this, where it only has one x-intercept there. These are both cases where d, the discriminant, would be equal to 0. If the discriminant is positive, remember, we separated it into if the discriminant was positive and a perfect square. I'll put here positive perfect square. And then it could also, again, be, and d is just all of this, right? D is just b squared minus 4ac. I'm just calling that the discriminant for d. It could also be positive and not a perfect square. But in both of these cases, the graph would have two different x-intercepts. It wouldn't be like when the discriminant was 0. The graph would have two distinct x-intercepts. So the graph could, and I just want to make sure we're clear here, the graph could open up like that, or the graph could open down like this. But either way, it still has two distinct x-intercepts. So there's that, and then there's this. Those are all the same examples, okay? With positive discriminants. So I know that we definitely have solutions. But we broke it down into those that were perfect squares and those that were not perfect squares because we saw that the ones that were perfect squares were ones that we could factor the equation. So if we could factor, we might get x-intercepts like negative 3 over 5, 0, and maybe 7, 0. Or we might get x-intercepts like negative 4, 0, and then positive 1 over 3, 0. We get nice rational x-intercepts when the discriminant is a perfect square that we could factor. If the discriminant was not a perfect square and we could not factor and we had to use the quadratic formula, we might get x-intercepts like negative 3 minus root 5, 0, and then negative 3 plus root 5, 0. Or we might get x-intercepts like negative root 6, positive root 6. So we still get real x-intercepts, they're just not rational numbers that we get for our x-intercepts, they're irrational numbers. The last scenario is if the discriminant is negative, then the graph would have no x-intercept. If the discriminant were negative and we had imaginary zeros, the graph would look like this and be either entirely above the x-axis, or the graph would look like this and be either entirely below the x-axis.